Now, welcome to Electrical Machine Lab 1. Today, we are going to perform polarity and ratio test on single phase transformer. Okay, so in this test, what is the objective? Objective is to confirm the voltage ratio and current ratio and to identify the polarity of the transformer. So in case of any transformer, either you are going to purchase the transformer or you are manufacturing the transformer, you have to conduct a polarity test and as well as the ratio test. So ratio test is going to confirm that the voltage ratio is correct at a different voltage level as well as the current, isn't it? So suppose this is the it may be a three-phase transformer, it may be a single-phase transformer. So voltage ratio is going to confirm with the help of voltage ratio test, and the current ratio test is going to confirm by loading the transformer at some particular values and to see whether the ratio is correct or not. At the same time, it is going to conclude that the VA rating of primary and secondary winding is quite same. Only the difference is that when we are going to conduct, because in case of the primary winding, as it is connected with the source, it is having some magnetizing current. So slightly the variation in the current ratio we are going to observe for the small transformer. But if the transformer capacity is larger, this deviation is very small. Okay. So under test we have taken a 2 kVA 230 by 115 volt single phase transformer. This is our under test. So this is HV winding, it has a large number of turns, and LV winding, it is a less number of turns, is that. So this winding is up to the 230 volt, whereas this winding, LV winding, is 115. Okay. Now what is the practical setup? It is connected with the single phase auto transformer. Initially the voltage is very small, or you will start from the zero value. Now the selection of voltmeter and ammeter, definitely when the voltage is high, we have to take the voltage range of the voltmeter. AC voltmeter is 0 to 300 and current range is 0 to 10 ampere. Because the full load current or the rated current of the transformer is around 8.5 ampere on the HV side, and for the LV side it is 16 point something or 17 ampere is there. So we can selecting depend upon the rating of the transformer, voltage, voltmeter and ammeter. Similarly, in the secondary side, the voltage is only 115 volt. So for the proper resolution, we have taken the voltmeter range is 0 to 15 and current range is 0 to 20 ampere. Okay. Now initially the switch is open, so there is no load at all. Only we are going to test the voltage ratio. Okay, so slowly increase the voltage, no doubt, up to the 230. You can go up to the first is the 100 volt, then 150 volt, 200 volt, 230 volt. So any step you will start from, say it may be 100 volt. Okay, so what would be the, say, 120 volt and so on up to the 230 volt. And we are going to observe the your secondary voltage, and from this voltage V1 upon V2 is going to be it is same for all readings. So that is the voltage ratio test. Similarly, to conduct the current ratio test, so definitely it has to be loaded. So we will switch on the we will close this switch as is there, and we start the loading of the transformer in step. So particularly, say if you are keeping the voltage is 230 constant, and if you load the transformer, the current in the secondary winding get increases because of the increase in load, and the reflected current in the primary winding also get increases. So by this way we can have some current in the primary winding and secondary winding. But the primary winding current is slightly higher because of the exciting current, because of the no load current, which is going to overcome the iron losses and set up the magnetic flux in the core. So as it is a small capacity transformer, the ratio you are going to look, the ratio is somewhat different as compared to the voltage one. But if the transformer capacity is very large, therefore the exciting current is very small as compared to the full load current. So this is the voltage and ratio test on the single phase transformer. We can test the same on the three phase transformer. Only the difference is that there is a three phase transformer is there, three phase supply is there, and the load which is going to connect, again it is a balanced three-phase load is there. So this is the voltage ratio test. Now second part of the practical is the polarity test. Polarity test, why it is needed? The polarity test is needed generally when we are connecting two transformer in parallel. Otherwise, if the voltage is different, if the voltage in the same direction, then it will give the total voltage across the load is very high and it may lead to the dead short circuit. One thing is there, and second is to identify the vector group also. So we are going to identify what is the polarity of the transformer. Polarity of the transformer is that under some particular instant the voltage induced will be in the same direction. Okay, so here again the polarity test, it is a open circuit, permanently open circuit is there, and the rest of this one again it is HV winding, LV winding. We have taken the same transformer. Under test it is a 2 kVA 230 by 115 volt single phase transformer is there. So the primary voltage, primary voltmeter ammeter and secondary voltmeter and ammeter will be the same as per the which we have taken the criteria for selecting the voltage range and current range of the different ammeters. Now in this test, what we have done, we have connected the second terminal of the transformer is directly connected to each other, and one terminal is connected with the voltmeter. And definitely the voltmeter range, here the selection of voltmeter range should be in such a way that it should be the addition of HV winding and LV winding. So it is a 230 plus 115, so it is somewhat higher, and therefore we have connected the voltmeter range, or we have selected the voltmeter range is 0 to 600. Now again what we will do, we will apply the rated voltage. So rated voltage is 230 here, 115 is here. So if the voltage is, both are in the same direction, if suppose the voltage ranges are voltage induced in the same direction, then the voltmeter will observe the difference of these two readings. And if the voltage induced in opposite direction, definitely the voltmeter is going to induce, or voltmeter is going to measure the addition of these two ones. Means 230 plus 115 will be the voltmeter reading. Otherwise, if this is shown the instantaneous polarity, if it is such that, then the voltmeter will measure the difference of these two elements. Means 230 minus 115, so voltmeter is going to measure only 150. So what would be our observation? Observation is the say 230 volt we are going to apply. We are going to induce the secondary voltage is 115. Now you have to observe what is the value of voltmeter. Either it is W1 plus W2, so you write down here. If it is W1 minus W2, so you can say that the mark polarity is same, or you can write mark polarity is opposite. So this is our result. If W1 plus W2 is the reading of this voltmeter, then the polarity mark is opposite. If the reading of voltmeter is V1 minus V2 is the reading of 115 volt, then you can say that the polarities are correct. So this is the way by which we can conduct the polarity test and the ratio test on single phase transformer. So now we will move to the practical setup, and by conducting the practical one, we can conclude the result, and we can write the we can conclude the entire practical as well as find the results.